Hello everyone, welcome back to my YouTube channel Katia Surface and Part Design. In today's video, we will discuss about the DFMEA. What is DFMEA and why it is important in a product design and how can implement it step by step in projects. So let's start DFMEA. So we will cover all these topic. What is the DFMEA and how to implement, and what is RPN, risk priority number, and what is the P diagram and what is the B diagram. So move on the next slide. DFMEA. DFMEA stand for Design Failure Mode Effect and Analysis. What is the definition of DFMEA? It is a structural analysis used by an engineer to find and fix potential failure in a product design before it reaches to customer. And how we can say in another way of DFMEA. DFMEA is a systematic approach used in design phase to identify potential failure mode and analyze their effect and take action before the product reaches to the customer. So what are the purpose of DFMEA? To identify design failure early, to analyze their effect, and to prioritize the risk, and then take action to reduce eliminate those risks. And I also I also represent the purpose in a chart way, so you can see here. So now we are discussing step by step. Identify the process, and then what can go wrong, and then what is the system effect on your on output, on your system, on your part. After that, what is the severity? Severity means how bad effect of your part, of your system. And then what are the causes? What are the causes? After that, how often? And then current control, ability to detect means how we can find it the failure, how we can control the failure, and then how well, and then calculate the RPN. RPN means risk priority number. RPN is equals to severity multiply occurrence multiply detection. If if the RPN is higher, so we need to take action as a higher priority, and then plan for the corrective action. What are the failures coming in your system? What are the causes? So to resolve all the issues, we need to plan and then solve it. So move on the fourth slide. So in the fourth slide, we represent this example for the door latching. So what are the failure mode? What failure mode coming in will come in the door latch? So that does not latch properly, and what will affect door open while driving, and what are the causes? So weak latch, design. So many reasons for the not working of door latching, and then calculate the severity and occurrence and reduction. So we calculate the severity is 9, and then occurrence is 4 and detection is 3, and calculate the RPN. So RPN is equals to severity multiply occurrence multiply detection. So 9 multiply into 4 multiply into 3 is equals to 108. After that, we need to take action to resolve the issue of door latching not working properly, and what are the effects. All the issues we need to close with the help of the DFMEA, and then move on the fifth slide. So in the fifth slide, we are discussing about the P diagram. What is the P diagram? So P diagram is used before DFMEA to understand how a system behaves. It identifies input signals, control factor and noise factor, and output response of your product, and what are the error states. And also I mention the definition of P diagram. So P diagram is a diagram that show how a system या part work by connecting with the input या output या noise factor, the control factor and the error states. P diagram it helps to understand what is coming into the system is called the input, and the function what system is doing, what can disturb it, what you can control, what problem can happen, and why it is important of P diagram. So it helps to set the context for DFMEA by understanding all possible variables and intersections. And then move on the sixth slide. Sixth slide is for the B diagram. B diagram means boundary diagram. It is a diagram that show your part and all the nearby system and connections. It explain who touches whom, means which part touches to the which part touches to your part, and where energy transfer and where the materials transfer, where the signal passes, and where problem can happen in your part. So all the inputs we will we will see with the help of the B diagram. So what are the purposes of B diagram? So purpose of B diagram is the identify the interface like physical contact and electrical connection and then energy transfer, and then identify potential failures area at boundary, help in making a better DFME. And why B diagram is important? Find a critical contact points, understand material flow and material transfer, find a risk point early making DFME. And also and also you can see here the chart how we can show the physical contact and the material transfer and the material boundary contact and the data information and the energy transfer with the help of the signs arrow. And P means P stand for the physical contact, E stand for the energy transfer, and the I stand for the information exchange, and M stand for the material transfer. And also be here the numbers ki P minus 2, like P minus 2 and minus 1 is 0. And what are the meaning of the minus 2 minus 1 and 0 1 2? So you can see here. And then I also explain the B diagram I also explain the example of B diagram for the seating system. So neighboring part of the seating system is the seat frame, seat cushion, seat cover, recliner mechanism, slider, and airbag system, and vehicle floor, and seat belt buckle. So what are the type of interface for the all the neighboring part of the seating system? So like seat frame. So seat frame, the interface of type of interface is physical mounting, and the seat cushion material contact with the seat frame and with the seat backrest, and also seat cover material covering recliner mechanism, so mechanical movement lever motor slider physical mounting and movement, and airbag electrical connection, and then vehicle floor, so physical mounting and seat belt buckle. So type of interface is physical mounting and signal. So thank you. If this video helped you, please hit like and subscribe and share it with your team and your friends. Thank you.